I want to talk about a little bit about the science of sound. And some of you might understand all this stuff fluently, and others of you might not really understand much of it at all. So apologies if this is kind of rudimentary stuff. But I feel like it's very crucial to miking anything, but particularly a drum set where it's you might have very many mics being used to capture the drum set. The drum set, some people look at it as one instrument, other people look at it as a collection of instruments, but more than likely you're going to be using more than one mic on the drum set, so there's going to be a phase relationship between those 2 or 3 or 15 mics. So the more you can optimize your phase relationship between the microphones, the more pure and punchy the drum tone will be. So I want to make sure everybody understands what phase is and the difference between phase and polarity, because I think that those two terms get thrown around and used interchangeably a lot when in reality they're not the same. So sound is a pressure wave, and so as sound is approaching you, it's what is it? Sound is I think I wrote this down here. Did I write it down? Yeah. So speed of sound at sea level and relatively low humidity is about 1,126 feet per second. So we're in Seattle. We probably have higher humidity, so maybe it's a little bit slower than that. But sound as compared to say light or electricity moves quite slowly. And what sound is it's a pressure wave. So as I speak towards you, you're hearing my voice because you're getting these oscillating contractions and expansions of air pressure. So, and that air pressure goes to your ear and then causes your ear to vibrate, and then your brain interprets those vibrations as a sound. So, the simplest type of way to represent a sound wave would be to just sketch out a sine wave. And I'm going to do that on this whiteboard over here. So, let's draw a little axis. We've got our X and Y axes here, and X is going to be time, and Y is amplitude or volume. So the simplest sound wave that we can draw is a sine wave. So one period of a sine wave looks something like this. Sort of a neutral sine wave would say be a 1 kilohertz sine wave. That means 1,000 cycles per second. So that means you get 1,000 of these per second. And I have a little audio example of that back here in Pro Tools. So I'm going to go to Pro Tools for the first time and just play what a sound wave is, or excuse me, a sine wave at 1 kilohertz. How do I work this thing? There we go. That's a sine wave. So let's talk for a second about miking just a simple acoustical membrane, like a single-sided drum head. So let's say you have like a Remo Rototom or a Timbali or something like that. It's a single-sided drum head. I'll just draw it sort of two-dimensional. Let's say this is that's the drum, the shell of the drum, and this is the drum head. So you're looking at the drum head from the side, okay? And then let's mic up this drum head with, say, standard microphone there. You strike the drum head with a drumstick and start it resonating, and the initial strike of the drum set pushes the head down away from the microphone. So the first thing that the microphone sees is the drum head moving away from it, which is a negative amplitude. So this is a positive direction, this is the negative direction. Now, let's say we want to double mic the drum. We want to mic the top and the bottom of the drum. We're going to use the exact same brand and model of microphone, and we're going to use the exact same mic preamp. So everything is set to the same gain, has the same frequency response. Okay, now we've got another mic on the bottom of the drum set. Now, when this stick strikes the head again, its initial amplitude is being pushed towards the bottom mic. So electrically, since electricity actually moves near light speed, according to your recorder, it doesn't care that there's no matter where you position the two mics, it won't perceive a difference in time due to the speed of sound. It will, or due to the speed of electricity. You can use like a 500-foot mic cable here and a 5-foot mic cable there. Electrically, they're essentially the same. I mean, obviously there's cable capacitance and all that stuff, but in terms of the speed in which electricity travels through the mic cable, it's essentially the same. You don't have to worry about that difference. So what you're getting with this bottom microphone at the initial strike of the drumstick is a membrane moving towards this microphone. So it's moving away from the top mic towards the bottom mic. So the bottom mic sees a positive amplitude, okay? So this is okay. So this is what the, I'm a little backwards here, but this is what the top mic is seeing. Or sorry, this is what the bottom mic is seeing. And then the top mic, yeah, I should have drawn this backwards. The top mic is seeing that. So let me show you sort of the difference in tonality between this sine wave that starts with a positive amplitude versus a sine wave that starts with a negative amplitude. And I can do that back in Pro Tools just by creating a duplicate of this track. And let's see, I'm just going to solo that guy. And then we're going to use Audio Suite Invert. And this is just a quick Audio Suite plugin that will invert the polarity of that sine wave. So let's blow up these tracks a little bit, just so we can see them a little bit better. And so now you can see that the duplicate is exactly the same in the x-axis, but 180 degrees reversed in the y-axis. So just here's how the regular sine wave sounds, right? And here's how the inverted sine wave sounds. It's exactly the same. You can't perceive the difference, but if, I think my solo mode is wrong here. How do I do this? Solo, latch. If I play these together, there's no sound. They perfectly cancel each other because they are perfectly out of phase. So if our little drum example over there, if it's a perfect universe, it's in an anechoic chamber and the membrane sounds exactly the same on both sides and the microphones are 100% identical and the entire signal path is identical, those two mics would essentially cancel 100%. Reality obviously is a lot more complicated than that. But this is sort of an illustration of what polarity is. So just the physical inversion of a signal is polarity. However, so phase is actually a time discrepancy. Let me go back to the whiteboard for a second here. Now, let's just forget about this bottom mic for now, okay? And you know what? I'm going to redraw this. So here's my drum again. This is the membrane here, and this is just sort of cross section of the edge of the shell. And here's my microphone cable, and it's it's pretty close to the shell. And then let's say now I have an overhead microphone. So positioned up here is my overhead. Okay, so what happens now? We have to remember that, like I stated earlier, electrically, your recorder, whether it's a tape machine or a DAW or whatever, is seeing these two microphones at the same time. But because of the speed of sound, the sound from this drum head is not arriving at the two microphones at the same time. So I did a little math on my own and determined that let's say that this drum head is putting out exactly a perfect 1 kilohertz sine wave. It takes that sine wave. Let's see. Actually, we've got to refer to my notes here. Okay. So a 1 kilohertz sine wave has a period of of 1 millisecond, because it's 1,000 cycles per second, so 1 period is 1 millisecond. So for 1 period, that sine wave will move 13.5 inches. So half a period, so let's say the overhead mic is only 6 3/4 inches from the snare drum. Obviously that's a very low position, but you're at the point, and I can illustrate this. If we go back to Pro Tools, I can sort of illustrate this. Like, let me zoom in a little bit more. So let me actually undo that inversion. So now I have just a duplicate of the sine wave, which if I play it, is just louder than one happening at the same time, because now it's the opposite of canceling. They're adding, so the amplitude is doubled. So basically what we're saying is that in 13.5 inches, this pressure wave will have moved through 1 period. So 1 period of the sine wave is that, okay? So in 13.5 inches, it will have moved that far, which, let's see, let's go into samples here and see how far that is in terms of samples. Yes, it's about 44 samples. So let's say that we have this microphone 6 3/4 inches away from the membrane, the perfect membrane, the unworldly perfect membrane that's putting out a 1K sine wave. 6.75 inches away from that will give us half a period. So now we've moved in this case, I guess, 22 samples. And I might not have moved it exactly 22 samples, but we should have now, due to the timing offset, we have something that should mostly, it's not perfect, so you're still hearing a little bit of audio, but not much. We're basically fully canceling not because of a polarity inversion, but because of a time offset. So we use the polarity button on our microphone preamp to compensate for this phase discrepancy because of the positioning of the microphones. Now, in the real world, this phase discrepancy is nowhere near this perfect, and there's a lot of subjectivity to it, and it's, real world audio signals are not nearly as perfect as this sine wave, so it's comprised of many wavelengths stacked on top of each other, and we can't perfectly phase cancel or like volume cancel or volume multiply by doing this. But we can use the polarity switch on our console or mic preamp to compensate for this phase discrepancy. So science. In the case of a real drum set, we have probably many microphones. I mean, I typically record 12 to 15 microphones on a drum set, sometimes less, sometimes more. But each one of those microphones is, because there's not sonic isolation between each drum, each one of those microphones has a phase relationship to every other microphone. And we use a number of tools to combat those phase discrepancies. And the first one, the most important one, is mic positioning. And so you'll see me walking around my studio with a tape measure or with a string or a mic cable to measure distances between things to try to optimize certain microphones to get the best phase relationship between them. Sometimes after the fact, I'll scoot some tracks around digitally to improve their phase relationship. Other times it's just a matter of flipping the polarity button on a switch. That all being said, I should also say that sometimes perfect phase relationships are not what you want. Sometimes you get a greater sense of space when you have imperfect phase relationships. And equalizers actually work on the principle of phase discrepancies. So when you're EQing a sound, you're actually imparting a certain degree of phase shift in that tone. So sometimes you can use that to your advantage, and you'll hear that. Actually, I just recently watched a cool video that George Massenburg did where he's talking about miking a bass drum, or double miking a bass drum. And he'll actually use an inside mic and an outside mic and take advantage of the subtle phase discrepancy between the inside mic and the outside mic in order to kind of scoop out the low mids to get himself that whopping sub bass feel that he likes in his recordings. And you can do that. So don't feel as though you have to get everything in phase, but just be aware of what phase is and how it affects the tones of what you're recording.